New day, a new room. Linux login for SOC. Linux has been a leader in service and embedded systems, and now it is used even more widespread with the growth of cloud adoption. As a SOC analyst, you are now very likely to investigate Linux alerts and incidents, either from traditional on-premises service or from the cloud-native, containerized workloads. In this room, we will explore the most common Linux logs sent to SIM and learn how to view them directly on host. Learning objectives. Explore authentication, runtime, and system logs on Linux. Learn to commands and pitfalls when working with logs. Uncover how-tos like audit, monitor, and report the events. Practice every learned log source in attached VM. Complete. So recommendations room are Linux fundamentals, Linux shells, log fundamentals. Before moving, I just already moved. Okay, thanks for that. I don't need it. Now, log format, contrary to common belief, Linux-based systems are not immune to malware. Moreover, Linux targeted intrusions are a growing problem. Thus, as SOC analyst, you will often need to investigate Linux alerts. For this, you need to understand how logging works. Now let's clarify a couple of things and move on. By the Linux room refers Linux distribution, like Ubuntu, like we have in here. CentOS are here, see. The room focuses Linux service without GUI and goes not explained in desktop logging. We don't need that. Unlock the window. Linux logs most events in plain text files. This means you can read the logs via any text editor without need for specialized tools like Event Viewer or Relief. On the other hand, default logs are less structured, as they are not event codes and strict log forwarding rules. Most Linux logs are located in var log folder. Let's start the journey by checking this location. Look, we have in here, but cut is one. Follow syslog head and we got some commands to review. So now we can grab a call explain from results. So let me grep top, cut the scene, but grep crew. Oh, too much. Too much. Let me see real quick. How much is too much? Too much. So we have results. Let me behead them. Here we have some results. From results. Now discover logs. So if you want to discover logs, just did that. It is log LA. We have some really nice logs. Alternative audit. We don't have audit. No, we have audit. So grep our auth login session. Let me run this one for you. Grep our earth auth login session. More log. Too much, I guess. Too much. Okay, now, unlike Windows, Linux allows you to easily change log format, verbosity, storage location with the 100 of Linux distribution, which know to slightly customize logging. Be prepared that logs in this domain look different on your system or might not exist at all. We still are getting the logs. So we need to use syslog on the machine, which time server domain did the M conduct to say it's time. Let me search for NDB, I guess. Which time is no time. Which domain? We have domain in here. And what domain do we have? NDB. NDB.com. That's it. What kernel message from Yammer? Logs. Kernel message in the logs. Becoming mindful? What? I guess. authentication logs. Let me see. So this kind of log. Let me go real quick. Go in here, and we have auth and the structure of the auth. So we have event time, hostname, process ID, and message from the process. Can be of any format. Cut or less. Now, any format. So VM cron job. Home Ubuntu zip. Okay. Let me exit this one and cut out. Oh, look. Grep session open session close. Cause if I can type. Session open, session closed. Okay. Grep SHD open SSH daemon program that is like a service on Windows. Let me check this one. We have this closing failed. I guess we don't need to grep SSHD. Accept public key. Wrong password. Wrong port. Okay. Effects. So we have melee. Events. So cut this one and let me see. Pass the user add user not user scale. Once again, so you can see password change for Ubuntu. And now we have Xcalc and password change by root. Okay. Now lastly, we can get the command and this command su avd su. Okay. Continue with the logs. Which IP address failed? Multiple users. Yeah, SSH. Failed multiple users. And get me his IP address. So I can get it from 4. white spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Okie doke. We got this. So this one is unique. So this is it. 10, 40, 82. Which user was created, added to pseudo group. Let me use a command. Nope, not the command. This is it to pseudo group. Generic system logs. Linux keeps tracks of many other events scattered across files, kernel logs, network changes, services, cron runs, package installations, and many more. So we have kernel in here. Consider stream various events, packages in Debian, DNF packages on rel base. The listed logs are available during DFIR, but are rarely seen in a daily SOC routine, as they are often noisy and hard to parse. Still, if you want to deep dive into those logs, check out logs investigation. So this one is finished. App specific logs. In SOC, you might also monitor a specific program and do this effectively. You need to use its logs. For example, analyze database logs to see which queries were run, mail logs to investigate phishing, container logs to watch anomalies, and web server logs to know which pages were opened, when, and by whom. You will explore those logs in upcoming models, but if an overview here is an example from typical Nginx web server logs. Looks very cool, I need to say. Nginx, we don't have it here. So, Bash history. It is cut. Let me cut this one for you. Ubuntu Bash history. Nothing in here. Okay. Now, hello. Echo. Legit. SH. Bash limitations. Also, Bash Vista looks like little source. It is rarely used by SOC team. in their daily routine. Like you can simply add leading spaces to the command or it won't be logged. Okay, attacker can paste their command to hidden script from the bash. You mean don't save pin sh. I need to try this one. Nano legit sh and legit sh echo. This is a legit program. No voice. Message. Nothing. Permission denied. What do you mean? Oh. Let me see. So we don't have. Well, it can be right. So plastics legit and legit can be right. No worries. SH echo no longer right. Only brush. Exit. Let me cut brush history. Okay. This is it. This is it. Okay. So, according to manager log, which version of unzip? Let me return to the logs. See what do we have in here? ABD, I guess. ABD package. What arms? We have this one. Let me see. Indeed. What flag you see in the user's bash history? Let me see which users. History. of the users. Look, cut, wash, history. Remember, one of the users. So we have this one. Note to remember. Very nice. Next one. Runtime monitor. Monitor only auth log, bash history, but ignore runtime events. Okay, up to this point, we have explored various Linux log sources, but none can reliably answer questions like which program did Bob launch today, or who deleted my folder and when. It's because by default, Linux doesn't log process creation, file changes, network-related events, known as runtime events. Interestingly, Windows faces the same limitation, which is why Windows logging SOC we had to use sysmon. In Linux, we will take a similar approach, which is we have who am I? Let me see. System calls. Before moving, let's explore OS concept that might help to understand many other topics. System call. In short, wherever you need to open file, create process, access, camera, request, another OS service, you make a specific system call. And there are over 300 system calls in Linux, like exec v, executive program. Below is high-level flowchart and how it works. So, style program type. You shall start sending exe call, which Linux system call is commonly used to execute, I guess. Exec. Why do we need to know system calls well? All modern EDRs, logging tools rely on them. They monitor the main system calls and log detail in human readable format. Since there is nearly no way for attacker to bypass system calls, you have to do is to choose system calls you'd like to log and monitor. In the next task, we will try to practice using audit D. Can I type on the program? Open file. Yeah, nay. Nay. So, using audit D. Let me see. So we have rules. Always exit. Always open at. Secret. DHF. File secret. Low access to open. So we are granulate. me see. EDC audit rules. We have some of them in here. Wget, secret, and POC rule. So, in this task, we will skip configuration part and focus on how to read audit rules, how to interpret the results. Let's start from the rules instruction located in. So we have this one. Monitoring every process, file and network event can quickly produce gigabytes of logs each day. But more logs don't always mean better detection, since an attack burned in terabytes of nodes. Noise is still invisible. That's why SOC teams often focus on high risk events, build balanced rule set like this one. Let me see. And we have big file of the balanced rule set. Okay. So now you can view generated logs in real time, but it's easier to use search command as it formats the output for bare readability support filtering option. Let's see an example based on rules. Form the example above by searching. Search. Okay. I don't have a clue. Where are they? Let me help this one. Key string, search-based key field. And I interpret. Interprets the result in human readable. Wget. We have giant and enormous. Things. So we have PID. Where do we have it? Arc8. Timeout. The version of it. And 87. Cisco message from who initiated it. Configurations, and we have PID. I don't see it. Oh, Cisco. And we have PID. Okie doke. Audit user. UID on set. Very nice. User who ran the command. Root. TTY. Where do we have TTY? Command. TTY none. Okay. Exit. Absolute pass. Dash on the data power. And key. Optional tag specified by engineers. Audit rule use. Okay, let me see. Once again, audit rule. So we have in here, okay, book wget file DHM secret SSH config and Python net. Why net? Nobody knows. Okay, file net. So we have file this one. Let me change this one real quick. File SSH config. Okay. So user command config. So we have this information. Now you may have noticed an inconvenient output of audit D. Although to provide the verbose logging, it is hard to read and just enter C. That's why many SOC teams refer the alternative runtime logging solution. For example, Sys for Linux. A perfect choice if you already work with Sysmon and love XML. Falco, the modern open source solution, ideal for monitoring containerized systems, or SQL, an interesting tool that can be broadly used for various security purposes. EDR solution can track and monitor various Linux runtime events. Interesting. The key to remember is that all listed tools work in the same principle. Monitor system calls. Once you understand it, system calls, you will easily learn all mentioned tools. This knowledge also helps you to handle advanced scenarios like understanding why central action logged in specific way or logged at all, not logged at all. Now try to uncover threat actor with process creation logs. Task answer the questions. Great command. So, what was the secret file? When was the secret file opened? Okay. So we have DHM secret. We've got him. We finally got him. Come. Opened. What do you mean by opened? I guess car will be open. So let me take this one. 8, 13, 25, 18, 36, 54. Yes, sir. Yes, sir. What open? Original. What is the original file name downloaded from GitHub via wget? Let me see. So we need to see Let me check the grep option. Grep GitHub. We have it. We finally got him. So grep option is getting us names. Temp. Wait a minute. Process. File name. Downloaded form. File name is this one. Yes. Which network range was scanned using downloaded tool? Let me refresh the rule set. This is it. Net Python key. Now, book. Net Python. Nothing. What do we have? Okay. Book all. Book. Oh. Oh. Thank you very much. We have this range. Of addresses. Thank you very much. So, this is it. Great job exploring the Linux logs sources. Upcoming rules will put this knowledge into an action to trace and investigate a variety of threats targeting Linux systems from the initial access to the final attack. Steps you may need all learning log sources to fully uncover the breaches. Linux logging can be chaotic, but it often stores enough details to detect the threat. Logs are kept in var log folder by default, and I usually store in plain text. The top 3 log sources for SOC are auth log, app specific log, and runtime logs. Bash history is unreliable for SOC. Better use auditing or an alternative solution. Thank you, and that's it.